this is the Science Demystifier. In today's video, I will be showing you how to theoretically obtain your endpoint for this year's NECO Chemistry Practicals Volumetric Analysis. But before we go into the process, before we demystify the process, I want to encourage those people that are just watching me for the first time here on this channel to please subscribe to this channel. The subscription button is right below there. Please just click on it and then you'll be part of this move to educate people, to guide students and teachers out there on the right thing to do, to properly guide them. We are not we're not more intelligent or more exposed than you, only that we want to work together. Okay, so if you observe anything in the course of this video lesson or any comment you want to make to help us grow, please feel free to do that in the comment section, and then also like the video and share the video. Okay, all right. So without wasting much of your time, let us go to the board and demystify the process. Okay, all right. Welcome back. The first step to this theoretical verification is to first of all find the molarity of the stock solution, which is the tetraoxosulfuric acid, concentrated tetraoxosulfuric acid. And to find the molarity of the stock solution, you simply need to apply this formula. You can see the formula I wrote here: 10 times P times D times N. So what does P represent in this formula? P simply means the percentage. P is the percentage purity. Percentage purity. Now, when you buy this stock solution, if you look at the label on the stock solution, you will see the percentage purity written there. Now, we also have D in the formula, and D represents specific gravity. Specific gravity of the stock solution. Specific gravity. Now, in the sulfuric acid, the percentage purity, as always, there is around 97.999%, which is approximately 98%. And then the specific gravity of sulfuric acid is about 1.83. 1.83. That is the specific gravity for sulfuric acid. Now, molar mass of sulfuric acid, whose relative molecular mass is 8 to SO4, if you add up the weight of the atoms, the way it is done traditionally, you will get 98 grams per mole. So with these parameters, I can calculate the molarity of the stock solution, which is the sulfuric acid. So the molarity of the stock solution is now given as 10 times P, which is 98 times 1.83 divided by 98. So, of course, you have 98 up and 98 down. You can cancel that out, and then you're left with 10 times 1.8, and that will give us about 18.3 moles per dm cube. So this is the molarity of the stock solution. This is the molarity of the stock solution. So I'm going to teach you what to do with this molarity now. You are going to use the equation of dilution, because you are asked to measure 6.3 centimeter cube of this stock solution. Not 6.3, I think 3.8 centimeter cube, yes. 3.8 centimeter cube of this stock solution. And then you're asked to dilute it in 1,000 ml or 1 liter of water. Okay, so in one, you are asked to make it up to 1,000 ml, not to add 1 ml of water, okay? Because the solution is supposed to be a mixture of water and then the acid. So the 1,000 cm cube or 1 ml of the solution is supposed to contain both the acid and the water you're going to use to dilute it. Okay? Alright, so let's look at the equation of dilution. So I have my equation of dilution as C1V1. I hope it's clear. I hope you can see clearly from there. Okay, C1V1 is equal to C2V2. C1V1 is equal to C2V2. So what is C1? That's the initial concentration, and that's the molarity I got just now, which is 18.3. That's the molarity of the stock solution we just calculated. So times the volume of the solution you are going to measure. And that is the one that came out in the specimen paper as 3.8 centimeter cube. So you are going to write the volume of the solution, the stock solution you're going to measure. So that's your V1. Then your C2 is the concentration that you are going to obtain, which is probably the new concentration. That's the new concentration, which we don't know now. But through this calculation, we'll be able to get it. So C2 is the new concentration after dilution. So V2 is 1000, because the standard volumetric flask that most people use for this is the 1000 cm3 capacity volumetric flask. So that 1000 cm3 volumetric flask is what will be of V2, because they're going to fill up, the solution up to the 1000 cm3 mark. Okay. All right. So from here, we can make C2 the subject of the formula, and when we do that, we should be able to get 18.3 times 3.8 now divided by 1000. Divided by 1000. And when we do that, we should be able to get 0.0695. 0.0695 moles per dm cube. So already we have the concentration of the sulfuric acid, which is our Ca. Okay? Now, what about the second solution? The second solution is sodium trioxocarbonate 4. And we all know that the molar mass of this compound is 106. And then we are asked to measure 6 grams of this salt. We are asked to measure 6 grams of this salt. So because we are asked to measure 6 grams of this salt, it should be very, very easy for us to find the molarity of this solution simply by writing N is equal to small m, which is the reactant mass given to you in the question, because they said this mass must be to 1 dm cube of the solution, which means that this 6.0 can also be called the mass concentration of the carbonate. Alright, so 6.0 grams divided by 106. That is 6 divided by 106. And that will give us 0.057 approximately 0.057 moles per dm cube. So with this, I've gotten the value of my Cb, because I told you that this result that we have here is same thing as the mass concentration. That is the 6 grams we have here, because it was dissolved in 1000 cm3 of the solution. So the resultant solution we're going to have will be we have a concentration of 0.05 mole per dm cube. That's our Cb. Now that we have gotten our Ca and our Cb, it will be very, very easy now for us to find our Va. Va in this titration formula is the endpoint that is always causing the boost in the internet. People come to predict, to tell you that it is this or that or this or that. So in your own center, you can do this and be sure of what you're doing. Okay, so CAVA is equal to, CAV over CBVB. This is the popular formula that we all know. It's equal to NA over NB. So from here, I already have my Ca, which is the concentration I just calculated, as 0.0695 moles per dm cube. And then I have my Cb, to be 0.057 moles per million cube. And then I have my VB, so this VB, not VA. So my VB will be the volume of the pipettes used in your center, which is usually 25 centimeter cube. So that's your VB. Then your VA is the endpoint you're looking for. That's the endpoint you're looking for now. That's the endpoint. So your NA is equal to 1. So this NA and NB is obtained directly from the equation of the reaction, which I'm going to write now. So the reaction is between solid carbonates and sulfuric acid, which is tetraoxosulfuric acid. So when these two reagents, when they react together, this is the base, this is the acid. So you're going to have a salt, which is sodium sulfate plus carbon 4 oxide plus water. So if you check the equation of the reaction now, you discover that the equation is already balanced. And I can simply pick out the mole ratio of the base, which is NB, by looking at the coefficient of the compound here, that's 1. And then I'll pick out the coefficient of the acid here, which is also 1. So that's how I got the Na to be equal to 1 and Nb to also be equal to 1. So now I can substitute in my formula, okay? I can substitute in the formula. So the formula is CAVA over CBVB, and that's equal to NA over NB. So we are substituting now. CA is 0.0695. 0.0695. I believe you can see clearly from there. 0.0695. And then I'm going to multiply with VA, which is the endpoint I'm looking for, times CB, which is 0.057, times VB, which is volume of the pipette used, and that's equal to NA, which is 1 over 1. So by the time I cross multiply, I should have 0.0695 VA, and that's equal to, when I multiply the other side, that is 25 times 0.057 times 25, so I should be able to make VA the subject, and I have 0.05 times 25, now divided by 0.0695. So when I carry out this division now, I will be getting 20.5. I will be getting 20.5. I will be getting 20.5 centimeter cube. 20.5 centimeter cube. And that is the endpoint that we all are looking for. Endpoint. So your endpoint should be around this value. It should be around this value. Either, let me say, plus or minus 0.5 or 0.5 greater or less than, this value. Okay? All right. So that is how to theoretically determine your endpoint, for this forthcoming WAEC chemistry practicals. Okay? So shortly I will upload the video for the main titration. So just subscribe to this channel so that you get the video on how to carry out the titration, how to carry out the main practical. So this is the theoretical verification of the endpoint. So thanks for watching. See you in my next video. God bless you.